Question number 1, a mixture of carbon monoxide and carbon dioxide is placed in a container as shown below. A reaction occurs forming CO2. Which of the following best represents the contents of the box after the reaction has proceeded as completely as possible? Now, this looks very similar to a sample HSC chemistry question. You might have seen it, but don't be fooled. You want to read every question carefully. Don't go in with preconceptions, yeah? This question is actually not a dynamic equilibrium question. This question is a static equilibrium question. And the reason I know that is because there is no indication that the reaction has been reversed. The question tells me that a reaction occurs and it forms CO2. And then it tells me what's the box going to look like when the reaction has proceeded as completely as possible. Those two phrases indicate to me that it's a static equilibrium. So what that means is in a static equilibrium, it's not a reversible reaction. It goes completely to the right, which means my job here is to write out my chemical equation of carbon monoxide and carbon dioxide turning into CO2, and then figuring out what should be left over and what should be formed at the end of the day. So this is sort of a limiting reagent question from year 11 as well, because you need to see how much of each reactant there are, because that'll affect how much CO2 gets made at the end. So you have CO plus O2 turning into, remember, single arrow this time because it's an irreversible reaction, forming CO2. And for me to balance this equation, I need a 2 on my CO and I need a 2 on my carbon dioxide. So then I have to look at my diagram. I have 1, 2, 3, 4 COs, and I have 1, 2, 3 O2s. So in terms of limiting reagent, my limiting reagent is going to be my carbon monoxide, okay? And the way I know that is because it's a 2-to-1 ratio. So if I have 4 carbon monoxides, I'm going to need 2 O2s to react all of it. But if I have 3 oxygens, I'm going to need 6 carbon monoxides to do that, which I don't have 6, I only have 4, which means 4 is going to be the one that gets completely used up. Okay, so what ends up happening is I react all 4 of my COs and I react 2 of my O2s, which means what I get left with at the end in terms of my products, I get 4 CO2s made and I get 1 O2 left over. Okay, so that's going to be what ends up at the very end of my reaction, which means that's going to be the option that I pick. So in terms of this, my answer is going to be B, because that forms my 4 CO2 and my 1 O2. The other ones aren't the answers. The other ones, this one forms way too many CO2s. This one doesn't form enough CO2s, and this one only forms CO2 as well. Okay, so this first option up here neglects the fact that there's some leftover O2s. And then if there was an option with the CO still in it, that means that the reaction has reversed to form some of your CO, and that would be a reversible reaction instead. In this case, it's not. So read your question carefully to figure out whether or not it's a static equilibrium or a dynamic equilibrium.